What diffusion is in chemistry is when a solvent dissolves into another liquid, the process of the molecules of the solvent moving throughout the medium of the fluid is what is called diffusion. This is lacquer thinner that has been used to clean the fuel tank out that had been contaminated with lacquer. And to it I'm going to add 100 milliliters of acetone so that we can see if the acetone will force lacquer out of solution with the lacquer thinner, and we could see diffusion at work. With this next series of experiments, I hope to demonstrate diffusion. And diffusion is the principle of how a solvent moves through a fluid medium. And what I'd like to be able to show is that agitation really isn't required to get the solvent to move through the waste oil to thin it. And the advantage of not agitating the blend is primarily we don't want to disturb already the particles that have already begun to precipitate out. And by using the principle of diffusion, the solvent as it moves through the medium will actually propel those particles out of solution as long as we're not agitating our solution. The other thing that I hope to show in this series of experiments is that once the solvent, such as gasoline, has gone into solution with the waste oil, such as vegetable oil and motor oil, is that the solvent will not come back out of solution. The only way to separate those two fluids is to run a fractional distillation to separate them. So what we're going to now do is I'm going to add, this is roughly 1 quart or 1 liter of waste vegetable oil that I just collected today, and I'm going to add to it roughly 200 milliliters of gasoline. And this container here contains roughly a quart or a liter of waste motor oil. And it's actually been sitting around for months, but it's still pretty thick. And I'm going to add, again, 200 milliliters of gasoline to it, and we'll attempt to observe diffusion in action. And we won't see much in the motor oil experiment except for one thing. We should see that the gasoline is not floating on top of the motor oil, but it's actually gone into it. In the case of the vegetable oil, we should be able to see the gasoline diffuse through the medium and not come floating to the top. And then what we'll do is we'll let these two samples sit around for a day, and we'll look at them after 24 hours, and then we'll look at them after a week to see if the gasoline is separated, floated to the top, or if it remains a uniform solution. And then at the end of that week, we'll pour off the waste motor oil blend, and we'll be looking for whatever precipitated out at the bottom, and we might actually see some precipitates at the bottom of the waste vegetable oil as well. I'm now pouring 200 milliliters of gasoline into roughly 1 liter of waste vegetable oil. Well, they seem to have gone one into each other, and I haven't even seen any turbulence of one fluid against the other. They are now uniform. This is 1 liter of waste motor oil, to which I'm going to add 200 milliliters of gasoline. I see no emulsion layer, and it looks as though the fluids have gone right into each other, but we'll give it a moment to see if any separation takes place. There's still no separation of the two fluids, so we can conclude that gasoline went right into solution with the waste motor oil and it did not separate. But we'll look at the sample in 24 hours and see if any separation has taken place. This is a sample of motor oil, waste motor oil at 80% with blended with gasoline at 20%. The sample was not agitated. The gasoline went directly into solution 24 hours ago. The sample's been sitting here unmoved for 24 hours, and we see no separation of the gasoline from the motor oil. This is a sample of waste vegetable oil that had been blended at 80% with gasoline at 20%. And it has sat undisturbed for 20 hours or 24 hours, and there is no sign of the gasoline separating from the vegetable oil. This is a sample of waste motor oil that I added gasoline to at 20%, and I left it sit for a week. And as we can see, there is no emulsion layer forming, which means the gasoline is not floating on top, nor has the gasoline or vegetable or waste motor oil separated. This is a sample of waste vegetable oil to which I added gasoline at 20% about a week ago. And as we can see, no emulsion layer has formed, and which means that the gasoline and the vegetable oil have not separated, and it did not require agitation to force the gasoline into solution with the vegetable oil. They just went into solution and they have not separated. This is a sample of new motor oil that was blended at 80% with gasoline at 20% about 6 months ago. The sample has sat on the shelf in my workshop that whole time. The gasoline and vegetable oil blend was never agitated, and there's no sign of a separation of the two fluids, and that there is no emulsion layer formed to indicate that the two fluids have separated. This is a sample of new canola oil blended at 80% with gasoline at 20%. It is a sample that was made 6 months ago without agitation, and it has sat on my shelf for the duration of this 6 months with no indication of the gasoline and vegetable oil separating, as there is no formation of an emulsion layer. This experiment should allow us to conclude that at no time does gasoline ever float on top of any oil. It will dissolve immediately into the oil without agitation, and will remain in that oil until it is separated through fractional distillation. Anyone who claims that gasoline floats on top of waste motor oil or waste vegetable oil has to either be in error, unable to be a reliable observer of reality, or may have an agenda to discourage people from blending, possibly because that individual makes a living with either selling products and services for biodiesel or for two-tank systems.